So today we will try to explain the concepts of artificial neural network. By artificial neural network, you know, the basic backbone of AI, artificial intelligence, is actually ANN. AI runs on ANN. And what is this ANN? ANN is the artificial neural network, which is a very popular method for prediction, optimization, or simulation objects. And ANN mimics actually the human nervous system, and they solve the problems in a parallel manner. So how they mimic the nervous system? Take the example of a baby. Whenever the baby touches a heated object, what happens is he sends immense pain due to the heat. And this pain, when received by the hand, it is transformed to the brain. And brain, what it does is, due to the reflex arc, what it does is it asks the hand to remove it from the heated object. So what happens is, this is whenever the baby touches the heated object, this is what is our question or query. And this query is transferred to our central nervous system, and based on the experience stored there, what it does is it responds to move its hand or move his or her hand from the heated object. That is the response. So this simple thing, now you'll say how a baby learns that when I touches the heated object, I have to remove my hand. Now, for the first time when the baby touches that heated object, it senses excruciating pain. And this pain is transferred or converted into its experience in the central nervous system. So what the central nervous system does is it stores the experience and it tries to learn from this experience. So what happens is, the next time when the baby touches this heated object, he will straight away remove his hand based on his past experience. Right? Now, how this neural networks or our neural network learns the problem? What happens is, there are, as you know, we have senses. We have touch sense, we can see, we can feel the touch, we can hear, and all there are senses that we have. And what happens is, these senses actually are also known as receptors that are placed in our skin, in our ear, in our eye, and etc. So what they do is they receive the signal. They receive some information signal, which we can say as query, and these queries are transferred into the transmitted into the brain with the help of the nervous system. And these brain, what are they? They are they based on what they do is, based on the experience it has for these relevant type of experiences, it asks or it outputs the action that the human has to take due to that query. So let us take an example of when we study for exams. Okay, what we do is, suppose we have a set of questions and answers. Now when we study this set of question and answer, we memorize. Now in the test, when we get same or similar question, what we do is, based on the learning we have achieved by studying this set of solved questions, what we do is we try to solve the test questions. Now how brain remembers that or brain learns this. Now, this mechanism of learning based on study is, is accomplished with the help of something known as training. That is why we say more you train, more you learn, and more you can perform. Right? So you are training while studying this set of question answer. If you study only one time, you train the brain for one time. When you study two times, you train the brain for two times. So more you study, more the brain learns, more it becomes experienced, and more easily it can recall the unknown answers, or it can solve the unknown answers or unknown questions that it can answer. Right? It can answer the same question, or if you give similar question, it can also solve it with the help of the set of training question answer that you have already studied. So this technology, this technique is actually mimicked when we try to develop a numerical model with the help of ANNs. Now, with the help of ANN, you can develop prediction model or predictive model, optimization models, and also simulation models. Now, in case of prediction model, predictive model, what you do is you try to predict something which is unknown. Suppose if I say that what will be the rainfall in the year 2000, suppose 30, January. Let us be more precise, 2nd January. So we do not know because this date has yet to come. So how we can predict it? You have to develop a model and you have to train the model with the help of the rainfall of January month for the previous years. That is from 2022 to suppose 2000 or 2010. Here also, more the data of rainfall in January you have, better will be the model prediction. So similarly, if I want to predict the what I can say the runoff for a certain rainfall, then this model which based on the input value of rainfall tries to predict the output runoff. So these, if we are to develop the model, then we have to train it based on the existing data of rainfall and runoff. The same day rainfall, same day runoff. If we have the known data and if we train the model based on the known data, then only we can predict the runoff for a rainfall which is yet to take place. Right? So this is known as prediction. And what is optimization? Optimization means if this is the equation, suppose y is equal to x squared, and I say that yes, maximize this equation, maximize the value of this y. How can you do it? If I say that you have to maximize y based on the x, then how you can do it? You can do it by changing the value of x, right? So if you take x is equal to 2, y is equal to 4, then you take 3, x is equal to 3, y will become 9, and so on. Now you see what I mean is, I know that y is equals to x squared, and but I will say but I do not know what is the value of x. Here either this problem will also provide you some set values of x that you can take. They will say You can take x to be between 0 to 10. So, you know, you can take any value in between 0 to 10. And then what you will do is you will put 0, but you see here the value x must be more than 0. It cannot be equal to 0, right? And here also x can be less than 10 but cannot be equal to 10. So you can take a value, suppose 0.1, and then place it in x and you will get a value of y, and so on up to 9.99, or right. So within this range you can put the values in x and y will give it. Now here what happens is, here already y is equal to x square, I know the equation, but some problem may arise where this equation is unknown. At that time you have to develop a model, and you have to predict the relationship between the x and y, and then use that equation to find the maximum value of y based on the value of x. Okay, so here the equation is known, but if the equation is unknown, then you have to first develop the model and then you have to optimize. So when you are developing the model, you have to train the model, and when you are training the model, you will require some data where both input and output are known. Okay. Now, what is simulation? If I say what is simulation? Simulation is a scenario that is created to predict the future. Suppose if I say that rainfall will be very high and evapotranspiration will also be very high, then what will be the runoff? So here you see, I am saying that this will be very high, but reality may be different. Okay, so this is known as a scenario where you can imagine a situation, and based on that situation you can predict the outcome. This is known as simulation. Okay, now what happens is, for both prediction, optimization and simulation, you see the first step is to develop a model, and that model must be trained with a set of existing data where both input and output is known to us. Now, more lengthy or more exhaustive the data is, more better model you can develop. So, because as I have already explained with an example of studying set of question and answer, so more exhaustive the set will be, better you will learn and you will be better prepared for your test, right? So now what happens is, I'll come into this method representation, but before that, I want to say why ANN is important, why we are running behind this ANN. What is it? What it have which separate ANN from the existing linear and non-linear models. Now you see here the basic linear models follow like these patterns: y is equal to mx plus c, right? And when we try to predict this A and C, what we do is we have the known, if we have the known data of y and x, if we have the known data of both y and x, what we do is we put the values of y and x and then try to find out what will be the A and C. Now the problem is these models are not adaptive. That means it does not adapt with the input. So if this is the existing set of data, then this model will be prepared based on that set of data only. There will be no adaptation. By adaptation I mean based on the type of input data you have, the value of A, M and C will change. So your model, now what is the problem if the value of N and C doesn't change with X? Yes, what is the problem? The problem is that you see, when we develop a model based on the data available, we develop this model which can be used for predicting the output for the inputs which are either same or similar to the data by which this model was developed. Let me explain more. Suppose you are developing a model where I will give the rainfall and runoff will be provided or predicted. Now I have the data of suppose Howrah River. Okay. Now based on the data of Howrah River, I develop the model and then I try to use that model which was developed based on the Howrah River data to predict the runoff of Gumti River. Now you see, for linear models, as they do not add up with the inputs, what happens is, whenever you use a model which is developed based on the data of Howrah River to predict the runoff of Gumti River, error will maximize. Now if you use that model to predict the runoff of Howrah River for a rainfall which, which is yet to happen, then the error will be much less compared to when the model is applied to predict the runoff of Gumti River, because Howrah River data and Gumti River data is different. These are these two are different rivers and they have different pattern. Yes, I understand that basic relation is same, but the date there will be a difference in the data. Okay, so what happens is the error of the prediction for runoff of Gumti River with the help of the model developed with Howrah River, we will have much more error than when that same model is utilized for Howrah River. Right? This is the disadvantage of when the model parameters are estimated but cannot be adapted based on the change in input data. The model becomes data dependent and location dependent. Whenever the model becomes data dependent, automatically it becomes location dependent. So that is why what happens is, when you use, there are Dickens formula, there are Kosla's formula, there are many more formulas which help us to predict runoff. But as all of those models were developed based on the data of a specific river, that is why, other than when the model was used to predict the runoff for that river, whenever it is they are used for the other river, they will give large amount of error. That is when you are using Dickens formula in some Indian watershed, it gives much more error when Kosla's formula is used for predicting runoff for Indian watershed. Because Kosla's formula is developed based on the data of Indian watershed, whereas Dickens formula is developed based on the data of some UK rivers, okay? A river of England. So that is why, due to the difference of area, data is different, and the model, as it was developed from those data only, so they are failing whenever they have been applied to the other river. Okay, so in case of ANN, what happens is these M and C is replaced by weights W1, W2, W3, like these weights, and the C is replaced by something known as bias. Okay, right. Now here uh, You see, this is a schematic diagram of a neural network. So single layer neural network. You see, suppose there are n number of inputs and you have to predict one output. You remember what we do is we assign each of the input a weight. As you can see, W1 J, W2 J, W3 J, Wn J. J is output, and 1, 2, 3 are the inputs. What happens is we sum the product of input and the weight with each other. So what happens here is in this transfer function, what we do is we sum these values x1 into w1j plus x2 into w2j and so on, xn into wnj, right? Because there is only one output. After summing up, what we do is we use our activation function, right? And these activation function can be either sine function, either exponential function, or suppose it can be sigmoidal function. Okay, there are various type of activation function available in case of neuron. Now, what happens is this y is predicted like this: OJ activation function of the summation of the product value of the value of inputs and the weight assigned to that input, and all of these inputs multiplied by their respective weights are added to each other, and after that this activation function is applied on it and the output is given. Now the trick is what differentiate neural network from the other model is if there is a desired value already given, suppose OD, then what happens is OJ, what we do is we try to minimize this difference by changing OJ. And how we are changing OJ? We are changing, you see here, xn cannot be changed because its value is fixed, because you are learning from a given set of data. But you can of course change the value of weights. And these weights are taken any number, any random number, which can be either 0 to within 0 to 1 or more than 1. There are various different algorithms for this, which what those algorithms do is it changes the value of weight and try to predict new values of OJ for the same value of input. And why this new value of OJ is coming? Because we are changing WJ. Suppose if I first take the value as WJ is equal to 0.1. Now xn is same. So there will be a value of OJ for the Wn equals to 0.1. Now we compare this with this equation. In this equation, we try to find the value of the difference between the desired value of the output minus the predicted value of the output for the value of W as 0.1. So it will give a difference value. Now what happens is we again change the value of W. Now what? Let us say we take it as 0.2. Now a new OJ will be given. Again this OJ is placed here in this equation. And then a new difference will come. After that, what we do is we try to compare the earlier difference with the new difference. And if the new difference is lower compared to the earlier difference, then we again so what happens is so we try to minimize the difference, and when this difference is really lower compared to the earlier value, we try to vary the value of weight or in that direction only. Okay, so if we are increasing the value of weights from 0.1 to 0.2 to 0.3 and so on, then we go on increasing. But if in some iteration what we see is the new value is larger than the earlier value, then we try to change the direction of the value of weights. So we try to reduce it, and if after reducing also if we see that yes, the same thing happening, the earlier value is uh, better compared to the newer value, then what happens is we try to assign value or generate value in some another pattern, right? So these change in weights and updation of the difference between the desired output and the predicted output, this entire process is known as training. I will discuss it in detail later on. The point of the point that you must remember here is, here what happens is that this weight is changing, but this input is not changing, right? But in this case, y is equal to mx plus c, what happens is we are trying to find the value of m with the help of y and x only. We are not changing the value of m, and then there is no iterative process followed here. Yes, m, suppose this is y by x slope. So based on the value of y and x, m is fixed. Okay, so it doesn't adapt itself as it is doing in this case. How it is adapting? We are changing the value of weights constantly, right? So now you see here, this is a single layer network and this is a multi-layer network. What is the difference? You can see that in between input and output, there is a hidden layer that was introduced. And what this hidden layer is, if I hide this output layer, this hidden layer is the output to this input. And when I hide this input layer, this hidden layer becomes the input to this output. Now what happens is the learning process in case of single layer neural network is a one-step iteration process. But here, this single layer neural network, the process of information transmission from input to output in the single layer neural network is doubled, tripled, or multiplied by the introduction of this hidden layer. If there is only one hidden layer, it will be doubled. If there is two hidden layers, it will be tripled, and so on. And as you can see, more you can update the weights, better will be the predictive result. Why? Because there will be better scope of minimizing this difference. Okay. So let us go to next. Yes, let us take this example. This is your mathematical representation of ANN. As I have already said that this is a single layer neural network, right? These are the inputs. This is the bias, and this is the, what I can say is this is the weights. This H is the weight. Okay, and this is your activation function in case of single layer neural network. Now let me explain it with an example. Suppose there is a two input. So there are two input, one output, right? Let I assign them these two weights, W1 and W2. These are known as processing element or connections. And I assign this weight W1 and W2 to these two connections. Now what will be our Y1? Y1 will be some activation function. Let us say this is GA. Some activation function and the product of x1 with its weights W1 plus the product of x2 with its weight W2. Right? These will be your output Y1. Now what happens if the same layer, same input and output, number of input and output, this is 1, this is 2, and output is Y1, x1, x2. Here I put another layer with 3 nodes. Okay? These are known as nodes. This is input nodes, this is output node, and these are hidden nodes, what I say. And this layer, this is known as a layer, right? This is known as input layer, this is known as output layer. This is known as hidden layer. What happens is, you see, now we can draw the connection from each of the input layer to each of the input node to each of the hidden node, right? Right? And this hidden node can be connected to this output node only. Now if I assign the weights to each of these connections, suppose that this will be our W1, then what? Then W2, W3, then this will be our W4, W5, W6, and let it be W7, W8. So if this HN node, the hidden node, is named as H1, H2 and H3, right? Now you see this part of the network is exactly same as this one. If you replace Y1 with H1, right? Now this type of layer in this multiple network, there are how many number of this type of layer, this type of network is here in this type of network? You see this one is one such network, and this one is another such network, and this one is another such network. Sorry, yeah, this one is another such network. So there are 3 single layer neural network in this multiple layer neural network. Now, whenever I am replacing this Y1 with H1, this is this part, right? This become this part. And when I am replacing this Y1 with H2, you see this become this part. And when I am replacing Y1 with H3, what happens is this become this part. So now how you can predict H1, H2 and H3? You see H1, it is X1 into W1 plus you can say X2 into how much? I think here it is W4. Let me see, right? And you place a activation function here, that is be H1. Then H2 will be your A, H2, same input X1, but the weights will change. W2 plus X2, W5. And for H3, it will be H3. This will be X1, input will be same, but the weights will change. W3 plus X2 into W6. So here you can see that there are three nodes in this hidden layer. So we have H1, H2 and H3. Now if I try to predict this real Y1, this one, then what are the input to this Y1? H1, H2, H3, and all are connected to this Y1. Now if I try to predict the Y1 now, what will be it? Yes, again there will be an activation function Y1. Then you see here H1, H2, H3 are the inputs, right? So H1 will be multiplied with these weights. That means H1 will be multiplied with W7, H plus H2 will be multiplied with W8, plus H3 will be multiplied with W9. Here I am sorry, this will be W7, this will be W8, and this will be W9, not W8 as I earlier said. So H1 into W7 into and W9. So this will be the Y. Now you see we have already predicted H1, H2 and H3. Here you can see this is H1, this is your H2, and this is your H3. Just put the value of this H1, H2 and H3 here. If this is A, if this is B, if this is C, then in place of H1 put A, in place of H2 put B, and in place of H3 put C. Replace H1 with the value of A, replace H2 with the value of B, replace H3 with the value of C, right? So H1, the value of A that you have calculated here, you can replace H1 with A, you can replace H2 with B, and you can replace H3 with C. Now after that, what happened? W7, W8, W9 is there. These are three new weights. And as per the new another activation function, you can predict Y1. So you can see that the information is coming from this input. It is now dividing into the three layers, right? And then again converging into one node in the output. Now if you place another layer here, then what happens is these layers H1, H2, H3 become the input to these output. Suppose let it be H4, H5 and H6. So these will become output then, and these will become input. And after doing the operation, then this is output and these will become the input. So on. Now the thing is, more the number of hidden layer you introduce, better will be the learning process, more efficient will be the model you develop based on that learning process. However, the training time will be more, and the requirement of computational infrastructure to run the trainings will also be more, because more layer means more complex network. Okay, more heavier the network will become. So the calculation will be also very complicated, and more the complication, more computational infrastructure you require. That means more RAM you require, more cache will be required, and so more sophisticated computer you will require to run a very heavy neural network. Now you see, yes. So what are the basic methodology of AI? Right. Now the basic methodology of ANN can be divided into three parts. But before that, I want to discuss about the parameters of neural network. what are the parameters? Now, you know that in every model development procedure, what we do is we try to calibrate these parameters. In case of y is equal to mx plus c, m or c are actually the parameters which we want to estimate based on the known x and y data. Now, by this x and y data, so we try to predict m and c, and based on these parameters, once we estimate these parameters, we then use the x value of x to predict the y, and we check with the desired value of y, that is already available value of y, and based on the error or based on the difference between the already available value of y and the new predicted value of y, we decide the reliability of the model. And based on that reliability, we try to move into the next iteration or next procedure. Now, in case of ANN also, there are some parameters that we must estimate before you can develop a model with the help of these techniques. What are these parameters? First parameter is type of activation function. I say in the previous slides, I have already said what this activation function is. That is your y, then I have said that GA, and then this, right? It's just like this, plus A. Now, here H is your weight, X is your input value, is bias, and this is your activation function. And this is for single layer neural network. And for multiple layer neural network, there are two separate activation function, one for the input to hidden layer, another for the hidden to output layer. There are two different activation functions, right? Now, this type of activation function, that means what type of activation function you will use, that must be estimated or approximated first before you can develop a model, right? Second is number of hidden layer. I have already discussed about this. More the number of hidden layer, yes, accuracy will be more, but requirement of computational infrastructure and complexity of the model will also increase, right? So you have to decide how many number of hidden layer you want to use and what type of activation function. Here it is for the type of activation function that can be used for input to hidden and hidden to output. They can be same activation function or they can be different. Now this is first parameter, this is second parameter, and the third parameter is the main parameter, value of weights, right? At what value of weights, that difference, as I have discussed in the previous slide, OD minus OJ is minimum, right? These three parameters need to be determined. And remember, there can be a question that up to how much time will we iterate or will we constantly change the weights? At how much time? The moment you see this OD minus OJ becomes 0 or it is yielding the same value, suppose X, same X is coming for whatever change you made to weights, W's. At that time, you can stop the change of weight, and whatever the value of weight you have found for which this difference is minimum, you can take those values as the final value, and then you can predict the output which is not known to you or not the output that is not included in the training set of data, right? That output can be predicted based on some inputs by using the value of weights that you have determined. That means whatever value of weights you have determined, after which this difference becomes 0 or this difference doesn't change at all for many iterations, you take those weights and apply to your model to predict the output for those inputs whose output was not included in your training data, right? There's a test. Now you see, in reality, what happens is, what we do is, we divide the available set of data where the input and output is known into 70-30, not some do it as 60-40. That means 70% of data we'll use in training, 30% of data will be kept aside for testing the model, how good the model is developed. So with the 70% of the data, the model learns the problem, the inherent relationship between input and output. And after we found that this difference is not changing or it becomes zero, so at the weight at which this difference becomes zero or it is not changing at all, we take those weights and we apply to the input of these 30% data, where the output is known, but that part of the data is not included here in this 70%. So, such that we can validate or we can compare the predicted output with the available output, right? And after this was done, then only if we get satisfactory performance or satisfactory accuracy from that model, then what we do is we use that model to predict the unknown. That means we try to predict the output based on some inputs which is not included in this either 70% or 30% data, part of the data. So here you see now the steps. Selection of model topology. That means how many number of hidden layers you want to use, right? And what will be your type of activation function? Whether it will be sinusoidal, or it will be sigmoidal, or it will be exponential. The procedure is iterative. That means you have to follow that trial and error method. You have to first use one type of activation function for both input hidden and hidden output layer, and then you predict it and you compare it with the known outputs, and you try to optimize the or minimize this difference as much as possible, and then based on the minimization you have achieved, you then again change the activation function to some other activation function, and then you again do the same thing. You try to minimize the difference, and ultimately you will find something which may be zero or some value which is not changing even after changing the value of weights, and accordingly you will get a result. Now the activation function with which you get the best result, you will use that activation function in the final model topology. That means when you will predict the unknown for some inputs which are not included in the training data, at that time you will use that activation function for which you have get the best result during the training procedure. And same for the number of hidden layers. What we do is we trial and error. First we give one layer, then we give two layers, then we give three layers, and then also we change the number of nodes. So for all these combinations, whenever the result comes the best, we use that number of hidden layer for which we have received or we have achieved the most optimal result from the model, right? And this value of weights changing, I have already said, we constantly changes the weights, and then when we see that this difference becomes 0, OD minus OJ, or some value which cannot be changed even after changing the weights for many times. So at that point, what we found is at that optimal point, the whatever value of the weights is there, we use that value of weight for predicting the unknown. Okay, so that is was described here. Selection of model topology involves these two parameters, type of activation function and number of hidden layers. Then training for determination of the optimal value of weights. This is this parameter, third parameter. And after that, this validation of model is actually the testing of model. As I have already said, we keep aside this 30% or 40% or sometimes 20% of data, where both input and output is known. We do not include that set of data in this training set of data. And we use this set of data to test the model, okay, to validate the model. Okay, so how the model is behaving for a data with which it was not trained. Okay, just like how we take tests for students to analyze how much the student has learned. Okay, so this is a very example problem which is very simple. You see, suppose the input is 10 and input 1 is 10 and input 2 is 12, and we know that output is 24. So they are saying that find the value of output when input 1 is 5 and when input 2 is 7. If number of hidden layer is 1 and node is 2. Now here you note they're already saying, already defining one parameter as number of hidden layer is 1 and node is 2. That means the network structure will be like this. You have two inputs, so two nodes in the input layer. You have two nodes in the hidden layer. And they have said this is output 1, so output 1. So this becomes your x1, input 1, input 2. This is output 1, right? And these are, as they have already said, that take the hidden layer to be 1, number of hidden layer 1. So this is layer 1 hidden layer. And node is 2, so hidden node is 2. This is H1, H2. Now, how to solve it? So this network will be like this, 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 and this, and this, and this. So this is your W1, then W2, W3, and W4. There is no such nomenclature you have to follow. You can also say it as 1, then 2, then 3, then 4 also. There is no such predefined nomenclature, but it is better to name the weights like this, because then you can understand this, that W1 and W2 is for the first hidden layer, W3 and W4 is for the second hidden layer. And here you see this will be W5 and W6, and these are the weights of the connection from the hidden nodes to the output node. So what will be our first, as I have already described, what is H1? H1 is your x1 into W1 plus x2 into W3, right? X2 into W3, right? Now there will be some activation function also. Now regarding activation function, nothing has been said. So you have to use the trial and error method. Now what will be your H2? H2 will be, as I have already discussed, H2 is this one and this one. So your H2 will be x1 into W2 plus x2 into W4, I think it's okay. Because these two are 1 and 2. Okay, so more or less this is it, right? So what I have said is a little bit, you see this is H1, so this will be W1 and W2, right? And this is for H2, so this will be W3 and W4. So W2 is there and W3 and W4 is there. Right, so there is no H3, as for the previous example. Now what is our y1? It is h1 into w5 6. For all these cases, there will be some activation function, right? G1, G2, and here it can be given as a let us say, but they have not said what are the activation functions to be used. Here it is a schematic diagram of the problem that I have already discussed. Now here for the nomenclature, you know, this one is indicating, well, this is a nomenclature that we may follow, not mandatory. So this H1, this H1 is indicating the input 1, and this one is indicating the hidden node 1. Now you see here it is set 1, 2. So this one is indicating the number of input 1. This 2 is giving the hidden node 2, right? So here you see in case of the another one, what happens is this is input 2, so 2 towards the hidden node 1, so it becomes 2, 1. And this is input 2, and towards the hidden node 2, so it becomes 2, 2. Here 1, hidden node 1. So right, so here only 1 and 2 is there, node 1 and node 2. So this is node 1 and node 2. This is output 1, so it is output 1, output 1. Right, so this is the architecture. Then you see we have already discussed it. So these are the equation that we have already said. So here what is happening is, here by training data, we have a one set of data where it is saying that the input 1 is 10 and input 2 is 12, right? Now if you put it into the equation, right, in the equation that I've developed in the previous slides, you'd say your output, what will be your output now? So let us see how to do it. So first it is H1 and H2, right? And I have already draw this x1, I think W1 plus x2, W2, then this will be your x1, W3 plus x2, W4, right? Right? Now what is x1? This is your 10, this is your 12, this is your 10, this is your 12. So let us start the iteration process by changing the weights W1 and W2 and W3 and W4. So they have said that all these W1, W2, W3, W4 is 0.5. W1, W2, W3, W4 is 0.5. They are assuming like that. They are beginning from 0.5. If this is 0.5, then what happens is 10 into 0.5, 5. 12, 10 into 0.5 is how much? Can you say? 10 into 0.5 is 5, and 12 into 0.5 is 6, right? So what will be your H1? So it will be 5 plus 6, 11. Here also it will be 11 because these W's are the same, right? Now you have found out that H1 and H2 is 11. Okay, because 10 into 0.5 is your 5, 12 into 0.5 is your 6, and if you add it, it becomes 11. But now what is the activation function here? This is very important. So let us say we are not using any activation function. Later on we'll use some. We'll use sine function or tan function or sigmoidal function, any function you can say. You have to As they have not mentioned the activation function, you have to trial and error. Based on the trial and error method, you have to change the activation function and find the accuracy level of the model, and then you have to decide which one you can move ahead, right? So what means is 5 plus 6. Let us say there is no activation function here. So H1 will be 5 and H2 will be 6. That's all. H1 will be 11 and H2 will be 11 also, because the value of weight is same. Now what is the equation of Y1? This is nothing but, as you know, H1 into W5 plus H2 into W6, right? Now I know that H1 is 11, H2 is 11. Both these two, W5 and W6 is also 0.5. So this equation becomes 11 into 0.5 plus 11 into 0.5. So this 0.5 into 11 means 5.5. This part will become 5.5. This part will also become 5.5, right? And when you add it, 5.5 plus 5.5, this will also become 11. So this is just an example with arbitrary numbers. So this will become 11. Now, what is the desired value? Your input was 10 and 12, but your Z1 is 24. But you have predicted that Y1, which is the predicted value of Z1, to be 11. So what is the difference? 24 minus 11. This is your 13. Now, if you divided it by the actual value of the output, 24, 13 by 24 into 100, you will get the relative error of this. This is known as relative error. So you will get something, right? And when you get something, now what will happen is, now you change the value of weights from 0.5 to 0.6. Again, you put the value of weight W1, W2, W3, W4, W5, W6 as 0.6 now. Then you get the result of Y1, which is the predicted value of your Z1. Then you compare like this, find the relative error. If this relative error, the new one, is less than the relative error of previous one, then you increase the value of weights to 0.7, 5, 6, 7, and so on. So by this way, you continuously change the value of weights and see the relative error. When you see that this relative error is neither improving nor degrading, it is remaining the same, you stop changing the weights, and then with that optimal value of the weights for which the relative error is not in the best, what I want to say is the relative error is minimum. With that value of the weights, you try to predict the value of output for some inputs which are not included in the training set of data. So generally what we do in the testing step, we use that 30% of data that we have kept aside from the training, and we try to find the accuracy or the reliability of the model, and then we go for predicting the unknown for some inputs which are not included in the 70% or 30% of the available set of data. Okay, now you see this is more or less the solution of this example problem. Here you see I have used this logarithmic function log 10 basically. So you see that another thing you must assume is this A1, this bias, to be negligible. That means equals to 0, I can say. So here you see all these things I have already discussed with people. So you can here another point to mention is, here we have used the logarithmic function. So you can use this log 10 approach also, or A log A. This can also be taken, and there is no binding, no rules that for this you have to use log, for that you have to use sign. No, there is nothing. Based on only trial error, you have to find the most optimal uh, architecture of the neural network, right? So here you see we have solved it. Now, as I said, this is absolute error. They are using absolute error. I have shown you the relative error. The difference between absolute error and relative error is, in case of absolute error, if this is your desired output and this is your predicted output, right? Then by deducting the predicted output from the desired output, it will give you the absolute error. But the moment you divide that difference with the desired output, it becomes relative error. And you will always see that if the error is absolute error is less than 20%, then it is okay. Then you can stop, or as I have discussed already, the difference must be, that means difference between the predicted and desired value must be equals to 0, or some value which is not changing even after some predefined number of iterations. So by predefined number of iteration means, say suppose I have assumed that if the difference is not improving for more than 10 iteration, then I'll stop the training. Then I'll assume that no further improvement is possible. Now, sometimes we can take 100, sometimes we can take 5. It is up to you. There is no mandatory rule that you have to take 10 iteration or you have to take 100 iteration. It is solely upon you. If you want to wait up to 10, okay. If you wait up to 100, then time required will be more. If you want to wait until 5, then time required will be less. However, if you wait until 100, then you can be very assured that that difference will not improve at all. But if you take only 5 iterations and then decide that okay, no more improvement is possible, then you are leaving a chance of improvement, I would say, because sometimes it happens that at the 6th iteration, improvements start to take place again. And in case of every iteration, you have to change the value of weights by the same manner for each layer. Okay, so this is the thing. And sometimes we do like this, that all the weights is equal to 0.5, and if we change the weight value of 0.5 to 0.6, then all the weights will be changed to 0.6 only. And sometimes it happens that first 4 weights, we assume that it is 0.5, and then the last 2 weights will be 0.6. Yes, that can also be possible, right? But the change, if I then after that, if I say that okay, let it be 0.6, then this will be also 0.7. So the change must be uniform. Okay, and in case of activation function, you see input to hidden 1 is there, hidden to output is there. 2 activation function is there if there is only 1 hidden layer. If there is multiple times, then multiple activation layer will be there. So this thing is also required to be iterated. That means change it, see the difference, or this difference is also known as fitness function, and you have to goes on changing this activation function and evaluating the fitness function, and with the activation function for which the fitness function is most optimal, best, you have to keep that activation function at the time you are predicting the unknown from some inputs which was not included in the training or testing data. Okay, so this much you must remember. So these things I already